Hello. Do you realize that radioactive decay is very unique in the sense that it is spontaneous and random? And this makes it different from all the other kind of nuclear reactions. First, let's talk about spontaneous. Now, the uranium fission is not a spontaneous process because it doesn't happen until the uranium swallows a neutron. So there's an external trigger for uranium fission. Similarly, hydrogen fusion will not occur until two hydrogen nuclei collide with each other. And this will not happen until we have a hydrogen gas which is hot enough. But look at alpha decay. There's no external trigger. It just decays when it decays. Same with beta decay. This carbon-14 nucleus here may not decay for the next 1 million years. Or it may decay now. Because radioactive decay is a spontaneous process, the rate of decay of a population of radioactive nuclei is totally not affected by the environment. So whether this radioactive sample here is thrown into a hot cauldron or left in a cold vacuum, it will always decay at the same rate, at its own natural rate. Remember the Fukushima disaster? The explosion was not caused by uranium fission. The uranium fission is not a spontaneous process. In fact, after the earthquake, the neutrons in the radioactive power immediately mopped up. So without the trigger, the uranium fission was stopped immediately. But what was unstoppable was the radioactive decay of the nuclear waste, the fission products. It's the alpha and beta decay that causes temperature to keep rising until the plant exploded. If there were anything in this world that we could do to slow down the rate of decay, we would have done it right after the earthquake. And if we could do anything to quicken the rate of decay, we would also have done it. We will not be stuck with all this radioactive waste that remains radioactive till today. Now, radioactive decay is also a random process, which is kind of related to it being spontaneous. Because there's no external trigger, there's no way for anybody to predict when one single radioactive nucleus is going to decay. It's entirely probabilistic. It's entirely random. But exactly because it's random, the rate of decay of a large population of radioactive nuclei is entirely predictable. Because when it's entirely random, every single nucleus has the same probability of decay per unit time. The number of decay per unit time actually becomes totally predictable. We'll continue with that in the next video. Ta-ta!